Hi, this is question number 3 from the AQA Core 3 January 2013 exam paper. For the first part of this video, I would like you to try the question yourself. So if you'd like to pause the video now and give the question a go. Okay, well done if you managed to have a go at the question. I'm now going to go over a hint as to how you can go about answering the question. For part A, we need to find dy by dx when y is equal to e to the 3x plus ln x. So what we want to do is we want to differentiate each of these individually. So decide what happens when you differentiate e to the 3x, and we're just going to get a multiple of e to the 3x, and if you differentiate ln x, that's a standard differential that you should be able to find in your formula book. Okay, part B says given that u is equal to sine x over 1 plus cos x, we need to show that du by dx is equal to 1 over 1 plus cos x. So in order to solve this, we need to use the quotient rule, which can again be found in your formula book. So you can use this to work that out. For part 2, it says hence show that if y is equal to ln sine x over 1 plus cos x, then dy by dx is equal to cosec x. Well, we're going to use a mixture of the ideas that we've just found in part A and part B1. We can see that u is going to be equal to this part here. So if we use the chain rule, we've already found what du by dx is. We should also be able to work out what dy by du is, because we've done a similar thing over here, so we should be able to work that out as well. We can then use the chain rule to work out what dy by dx is. To remind you of the chain rule, I'll write it down over here. We've got dy by dx is going to be equal to dy by du times by du by dx. Okay, there you go, those are my hints. So if you'd like to pause the video now and see if you can have a go at working out the answers. Okay, I'm now going to go over the full solution to this question. So starting with part A, we want to find dy by dx when y is equal to that there. So dy by dx, and if I differentiate e to the 3x, I get 3 times e to the 3x plus, and if I differentiate ln x, I get 1 over x. And there you go. Part B, for the first part of part B, we're told that u is this, and we want to find du by dx, and I said that we can use the quotient rule in order to work that out. So du by dx, and that's going to be equal, and we're given the quotient rule here, but some of you might have a different way of remembering this. So we've got the differential of the top, which is what that is telling us to do, the differential of the top. So that's going to be cos x times by the bottom, which is 1 plus cos x, and we take away the top, which is sine x, times by the differential of the bottom, which is negative sine x. And that's going to be all over, and it's the bottom squared, so it's going to be 1 plus cos x squared. Okay, and I'm going to simplify the top, so that's going to be cos x plus cos squared x. and then we've got take away sine x times by negative sine x, so that's going to be the same as plus sine squared x. And we've still got that over 1 cos x squared. So we should be able to spot here that cos squared x plus sine squared x is equal to 1 using our trig identity. So this is going to be equal to 1 plus cos x over 1 plus cos x squared. So that's going to cancel with one of those, so we're going to have 1 over 1 plus cos x as required. Okay, so we've managed to show that du by dx is equal to that there. Okay, so B part 2, I'm just going to tidy up my area here a bit. Okay, for the second part of this question, I've got y is equal to the ln of sin x over 1 plus cos x, and we need to show that dy by dx is equal to cosec x. What I'm going to do is I'm going to use the chain rule here, and I'm going to start by saying that u is equal to sin x over 1 plus cos x. Okay, we've got chain rule written up over here, so I need to know what du by dx is, so I'm going to write that over here. And du by dx, well, we worked that out in part 1, and we've worked that out to be 1 over 1 plus cos x. Okay, I'm also going to say that y is going to be equal to ln u. Okay, because u is equal to sin x over 1 plus cos x, so y must be equal to ln u. So I can now write down what dy by du is, which is what I need for this part here. And that's going to be equal to 1 over u. And I'm going to write this in terms of x. So if u is equal to sin x over 1 plus cos x, then 1 over u, which is the reciprocal, must be equal to the reciprocal of this. So it's going to be 1 plus cos x over sin x. There you go. Right, so these are the bits that I need. I need this here, and I need this here. Okay, so we know that dy by dx is going to be equal to dy by du times by du by dx. So I can now say, well, that means that dy by dx is going to be equal to dy by du, which is this here, multiplied by du by dx, which is this bit here. Okay, now this and this are going to cancel each other out, so I'm going to be left with dy by dx is equal to 1 over sin x, and 1 over sin x is equal to cosec x, which is what we were looking for there. Okay, there you go. Hopefully you've found that useful. Thanks very much for joining me. I look forward to seeing you again soon. Take care.